Okay, so this is our hydrology literature presentation by Sophia Wall and Michelle Lise.
The article we read was called "The Effects of Forest Harvesting and Best Management Practices on Stream Flow and Suspended Sediment Concentrations During Snowmelt in Headwater Streams in Subboreal Forests of British Columbia" by J.S. McDonald, P.G. Bowdry, E.A. McIsaac, and H.E. Herenter.
So why was this study conducted? Research on the effects of forest activities on suspended sediment concentrations for large river systems only exists right now for coastal and southern interior rivers. There's not a lot of research for the northern boreal systems, which are different than the coast and the interior because they are snowmelt dominated regimes instead of a coastal system which has rain dominated regimes. Also, the practice codes of British Columbia legislation for riparian management is considered controversial in its effectiveness in protecting aquatic ecosystems. So they're going to review that.
The research objective was to test the efficiency of current BC legislation concerning riparian retention as best management practices for windrow. This study examines the annual patterns of natural variation as well as forestry influence, hydrologic, and sediment disturbances, also influence of stream crossing and access roads on stream sediment.
So the location was on three small headwater tributaries of the Baptiste Creek, which is north of Trembler Lake in Fort St. James Forest District. It's at the northern end of the subboreal spruce zone, and this is important because most of the data on this topic is only available for coastal streams.
So how was the study conducted? 3 creeks were selected and examined over a period of 5 years. In the first order creek, B5, all merchantable timber, which includes a pine with DBH of greater than 15 centimeters and spruce with a DBH of greater than 20 centimeters, within 20 meters of the stream were harvested. In the second first order creek, B3, all merchantable timber with a DBH of greater than 30 centimeters within 20 meters of the stream were removed. The third first order creek, B4, was left as the control to compare the first two.
Okay, so measurements of turbidity were conducted every 10 seconds over a period of 15 minutes during peak flow season. Total suspended sediment samples were filtered, dried, and measured to find the connection between concentration of suspended solids and turbidity. During snowmelt, the creeks were visited weekly to collect water samples and to locate any sources of sediment entering the creek.
The results. For both streams, B3 and B5, which are the two streams which the logging took place beside, there was an increase in peak flow and mean daily freshet discharge. B5 had the greater rates of the two. B3 and B5 had an increase in total suspended solids during the snowmelt freshet, and again B5 had the greater rate. B5 likely had the greater rates due to a log landing and a stream crossing.
The riparian treatments worked in protecting the stream banks from damage, but there's still a high possibility of windthrow disturbing the channel in the future, which will contribute to higher amounts of sediment in the streams. The study also found the best management practices for forestry activity near small streams should minimize the physical disturbances, channels like streams, crossings, road maintenance, and deactivation. So this table here shows the discharge and total suspended solid sediment between the streams and the control. So B3, B4, and B5 and B4, B3 and B4 and B5 and B4.
So why was this study relevant? Small streams are important habitat for fish, macroinvertebrates, and other species. They're also a local water source. High turbidity and high amounts of suspended solids can have a negative impact on the stream inhabitants and the users of the stream as a water source. For this reason, it's evident that forestry operators must be more aware of the impact forest activities are having on streams. That's the end of our slideshow. Thank you. Got it. I think we can probably cut out the end.